Okay, today's lesson for Algebra 2 is lesson number 81. We're going to be graphing what are called major X parabolas. So, to begin class, I wanted the students to start on Desmos and look at this equation. So if you plug this in on Desmos and then say add all sliders, it'll add a slider for A and then K and H. And I wanted them to mess with these sliders to see what effects they had on these parabolas. So one of the things that we saw that was different from yesterday's lesson is that when they have this form, the parabolas are sideways, so they're facing left or right, as opposed to up and down like yesterday's. Then A, so it says what does A do? Just like the parabolas yesterday, if A is closer to 0, the parabola is going to be wider. If it's farther from 0, the parabola is going to be more narrow. And the positive and negative also has an effect on it. So if it's positive, it'll be facing the right towards the positive numbers. If it's negative, it'll be facing the left towards the negative numbers. Or opening. We say opening right and opening left. Okay, and then H comma K is still the vertex here, so that's how those letters or the sliders for those would be significant because they determine what the vertex is. It's important to notice, though, that now H is outside of the parentheses and K is inside the parentheses with Y. Okay, so it kind of makes sense if you think about it because now because K is the Y coordinate in the vertex, right? It's H comma K. So this makes sense because it's grouped with Y now, not X. So that number that's with Y is the Y coordinate. And then the other number that's outside now goes to the X coordinate of the vertex. Okay, so moving on. Here's that basically repeated again. So these are the steps for graphing these types of parabolas. You're going to make sure it's in this form. And if x is first, like it is here, if it's x equals and then the y part is squared, then you have a sideways parabola. You identify h comma k as the vertex. And if a is positive, again, it opens right. If it's negative, it opens left. And you want to make a table. So you can use a similar shortcut as what we did yesterday. The only difference is that since we switched x and y here, we're going to be looking at y now instead of x in our table. So let's see what that looks like. Here's problems 1 and 2. So follow along here. First, I want to note that this first equation, it does have x equals and then the y part is squared, so I know it's going to be a sideways parabola. This is also the same as negative 2 times y minus 0 squared plus 0. Okay, so it looks a lot shorter, right, because the zeros just kind of go away and we don't have to write them. But that tells me that the vertex then is just 0, 0. And my A is the number out in front, so that's negative 2. Okay, then I make my table, but like I mentioned, instead of having x, we're going to have y now. So we do y and ay squared, and then plug in a, just like before, so this is negative 2 times y squared. And I'm going to look what happens if I go up or down 1, because this is y now, so y goes up and down, not left and right. So I'm looking, what if I go up or down 1 from the vertex, and what if I go up or down 2 from the vertex? So plugging in 1 here, I get 1 squared is 1, times negative 2 is negative 2. Plugging in 2, I get 2 squared is 4, times negative 2 is negative 8. Okay, and then I can plot these points and graph. So I start with my vertex, which is at 0, 0. Then I'm going to go up and down 1 unit, and I'll go left 2. Okay, that negative tells me I'm going to go towards the negative direction. So I'll go up 1 and then to the left 2 units. So that puts my point right here. And if I go down 1, I do the same thing, right? Down 1 and over 2 to the left. And then if I go up or down 2, I go to the left 8 units, so that puts me at these 2 points here. I can sketch my curve then, and that's what this parabola would look like. For number 2, my vertex here is going to be, I'm looking in with the y with the parentheses, or in the parentheses there's a y, so that number is going to be the y-coordinate of the vertex, and the x-coordinate will then be this number that's on the outside, so that's what goes with x, so my vertex is 2, 6 here. Okay, so then my a is still the number that's right out in front, so that's just 1/4 here. And I make my table with y and ay squared, which is going to be 1/4 y squared for this problem. I go up and down 1, up and down 2. Plugging in 1, I get 1 squared is 1 times 1/4 is 1/4. Plugging in 2, I get 2 squared is 4 times 1/4 is just 1. And those are my directions for graphing. I'm going to start with the vertex at 2, 6 right here. If I go up or down 1, I'm going to go to the right because it's positive, so I'm going in the positive direction. 1/4, so I go up 1 over, go up 1, and then I go over just 1/4. Okay, now if I go up or down 2, I'm going to go over 1. So I have these 5 points now, and I want to make my parabola. Sorry, I ran into that. Okay, so that's what it would look like here. Okay, so my tables down here are very similar to yesterday's, but again, instead of x, I'm using y. But this is the same process, right? I just plug in a, and then I plug in the y, different y values, to finish this table. And I need to remember, of course, that these are giving me directions, not actual coordinates. So I know if I go up or down from the vertex this many spaces, I get those following points. Alright, moving on then to numbers 3 and 4. So number 3, the vertex here again, I look on the outside first for my x, since x is on the outside. It's not inside the parentheses, so this is going to be 1 comma -4. Take the opposite of what's with y for the y-coordinate. Okay, and then a here equals -1/4. I make my table with -1/4 y squared. I am going up or down 1 and up or down 2. If I plug in 1, 1 squared is 1 times -1/4 is -1/4. Plugging in 2, 2 squared is 4 times -1/4 is going to be a -1. Oh, here's that work for plugging in 1 and plugging in 2. Okay, so my point is at my vertex, is 1, -4. From there, I go up and down 1 and over to the left. Since this is negative, I'll go over to the left 1/4. Going up or down 2 makes me go over to the left 1 unit, so I'm here. Those are the 5 points then. This is my curve. Okay, and again, similar for number 4. So in class, students did this one on their own. The vertex would be 1 and then +6. A equals 1/3. I set up my table with 1/3 in for A, plugging in 1 and then 2, squaring and multiplying by 3, I get 1/3 and then 1 and 1/3, because 2 squared gives me 4 times 1/3 is 4/3, which is just 1 and 1/3. Okay, plotting these points, I have 1, 6 as my vertex. If I go up or down 1, I need to go over 1/3, so those are those 2 points. If I go up or down 2, I'm going over 1 and 1/3, so I'm about here. And I can sketch my graph now. Okay, those are the only ones that we did in class, and then we went over the homework from yesterday and started working on this assignment, but I will do a couple more examples just so you can see some more if needed. Okay, so here for number 5, my vertex would be 6, comma, negative 2. A is going to be negative 1/2. And my table will look like this. Plugging in 1, I get negative 1/2. Plugging in 2, 2 squared is 4. 4 times negative 1/2 is negative 2. So from my vertex here at 6, negative 2, if I go up or down 1, I go back to the left, right, towards the negative side, 1/2. And then if I go up or down 2, I go to the negative side, I go 2 left. Okay, so those are my 5 points. This would be my curve. Number 6 is very similar. 1, negative 4 is my vertex. 1/3 is A. My shortcut table then looks like this. If I go up or down 1, that's just 1/3. Plugging in 2, I get 4/3 or 1 1/3. So starting at my vertex, I have these other points, and I make my curve. Okay, let me show those points again really fast. So if I start at my vertex, I go up or down 1, I go to the right 1/3. Up or down 2, I go to the right 1 1/3. Okay, and that's my curve. Alright, so that was it for today's lesson. We also talked about some closure questions. So we learned how to graph sideways parabolas using the equation and the shortcut method with the table. It's similar to yesterday's lesson because the equation is very similar. The vertex is still HK. A still affects the parabola by making it wider or narrower. And the method itself is very similar with the table, but what's different is that we're using y now in the table instead of x. We also have to use up and down instead of left and right to kind of describe what's going on with the y now in that table. And the standard form, or the vertex form equation, now has k grouped in the parentheses instead of h. So those are some of the things that are different here. But that's it for today. So go ahead and work on the homework, and I will see you tomorrow. Thank you.